Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We today have to start the process of actually using light probes in our game. We are switching to them because we wanted two things out of it. One, I wanted a more convenient way to sample sort of ancillary entities. So I wanted to be able to light everything in the game kind of easily and have everything go through a lighting pass more easily, hopefully. And so we want to take a look at that. But the other thing that we want to be able to do as well is we wanted to be able to reduce the number of light samples that we take. And because we had previously locked the number of light samples to be roughly the same as the amount of reflectors, that pretty dramatically affected our ability to place samples only where we actually needed them or wanted them. So what we're going to do today is we already did a bunch of the work for this like yesterday, but what we want to do today is to start the process of actually feeding like the lighting system with light probe information so we can start debugging and tweaking that process. Now, our goal for today, and probably next weekend, it's going to take, like I said, this is going to take a while because lighting is hard. There's just a lot of stuff you got to do. Our goal for today, and probably also next Saturday or something, is we want to get to the point where our light probes are working, but nothing else. So we're not going to try to change how the world is getting lit right now. We're just going to leave that exactly as it is. And what we're going to try to do is we're going to try to get our light probes working so that we can draw all of our light probes and see that the amount of light they claim is coming from each direction looks, roughly reasonable to sort of a cursory inspection. That's the first step in getting our light probes working. And for obvious reasons, I want to go there first rather than try to get everything working all at once, because what I'm trying to do, and you've seen me do this many times on Handmade Hero, is anytime you're working with a very complex system, especially one that is very hard to test, right? This is a very visual, approximate kind of a part of the code, right? Especially when you're working something that's pretty hard to test and pretty hard to know really, what you would put through it to say, yes, it's working, no, it's not. You want to try and find verifiable waypoints in that process so that you can do a small chunk, debug just that part, be reasonably sure that it's okay, and then move on to the next part. That way, you're not just blindly looking through a giant pipeline for where the bug might be. And so rather than try to debug things by doing the whole thing and then looking at why the lighting's wrong and having to just go, I don't know, is it because the probes are wrong? Is it because the shader's wrong? Is it because blah, 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 blah? What I want to do instead is just go, all right, let's try to get to a waypoint first, which is, can we see light probes drawn in the environment? Do they look like they're drawn roughly correct? So if I move a light around, do the probes near the light seem to be getting brighter? And furthermore, is like the up direction brighter than the down direction if the probe is high? And if the light is high, and if the light is low, is the down direction brighter than the top, right? And so that will give us a way of sort of verifying that our lighting solution is producing usable results in the propagation stage before trying to move to the stage where we're actually lighting the things in the game, and that way we can be more effective, right? We can have more effective debugging. So that's all we're doing. But like I said, lighting is complicated, so it takes a while. Even if everything goes well, there's just a lot of code. And so that's just how it works. Maybe someday NVIDIA will just solve this problem for us. If they get ray tracing good enough, you'd just make a call called GPU turn ray tracing on, and you'd have all your lighting done. I mean, I realize it sounds ridiculous given how much work lighting is, but if you think about it, that's how much work rasterization used to be. And nowadays, that is literally what you do. You make a call that's like, hey, here's a million triangles, draw them. And it just does, right? You don't do anything else. That would have been a ludicrous idea in, 1991 when, the people when Chris Green was writing a texture mapper for Ultima Underworld or something, right? If you told him like, oh yeah, like, well, actually it was earlier than that. It was like 1990 probably, right? If you're like, oh yeah, in 6 years, it'll just be like you make a call and the PC does all of that stuff for you. It'll be just like an SGI workstation, right? Anyway, so you never know, right? You never know. Eventually, we may not have to deal with this stuff, and that would be great because, hey, that's just more time you can spend on doing something else. Because it's not like we don't know what we want to have happen with the lighting. We do. It's just we have to make all these approximations because it's too expensive to try and compute real ray traced results every frame. Let's go ahead and open up our lighting system and see how we might proceed. Like I said yesterday, the biggest thing that we need to move towards now is that if you look at how our lighting is working, we have these light probes here that we need to operate on, and we don't actually send any down. Right. So that's really the entirety of the issue for us, is we're not getting any light probes. So before we can even start, we wrote a bunch of code yesterday. Before we can even start testing that code and seeing if that code works, or drawing the results of that code, or doing anything, right? We have to get light probes in here. So it'd be pointless for me to go take that code we did and try to like start moving light around through it or something, right? Because it doesn't make any sense. We don't have any light probes to start with. So the first thing we need to do is get the actual light probes in here. This is a plumbing problem. And so we're going to go ahead and try to address that. Now, if I remember correctly, we left ourselves, I think, I don't actually know if this is true. By the way, I need to update my remedy, don't I? Oh yeah, we're way behind. Can I do that here? I may not be logged in. I'm not logged in. Well, sorry about that. We'll get a new remedy soon, because there's a much updated version. Although maybe, I think George said he finished data breakpoints recently, so maybe that version will be out soon and we'll update to that. I don't think there's anything in particular I need right now, so I'm okay using the existing version of Remedy here, but point being, we're a little behind here. Sorry, I'm sorry about that, George. I gotta update this machine. I update my dev machine at work all the time, but I sometimes forget to update the Handmade Hero machine. All right, so here's the Win32 Handmade RDBG. I'm gonna load that up here. And if we run it, I think we just turned lighting off, right? And yeah, it looks that way. So you can kind of see here, like lighting is off entirely right now. I also don't know, is this a debug build or a regular build? I'm not sure about that part either. It looks like it's an optimized build. I'm going to go ahead and turn it into a debug build. And then what I also might do is I might go ahead and turn off whatever's slow about the lighting for the moment as well. So, oops, get that up there. So I believe if we take a look at what's actually happening in the game here, if I take a look at the profile, you can see that compute light propagation is still getting called, even though I'm not actually applying the lighting because I turned it off in the shader. So what I'd like to do now is I'd like to go into the lighting, because we don't need it anymore at the immediate moment, right? And compute light propagation here, I'm just going to get rid of that. So this function is just going to go away for the moment. And we're only going to actually put it back in here until we're only going to add it back in once I've done some work with the light probes and we actually want to run it. And so now if we run our system here, we should see some speed increase there, although... Okay. When I said we should see and blah, 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 what I meant was if you actually compile it properly, that's what's supposed to happen there. There we go. So compute light propagation also, remember, it's threaded. We do our light propagation on multiple threads because it's an expensive thing. All right, so let's try that one more time. All right. So here's our actual speed of the game in debug mode, which is good. Much better than it was. And now also, as I believe I mentioned this kind of, if you watched the whole series, you saw me say this 2 weeks ago or something when we did ground cover. You can see how expensive this stuff is getting. So render ground cover is very expensive in debug mode. If I actually change to release mode, obviously it gets a lot faster because it's just math ops that get optimized there. So, you know, if we're actually compiling in full release, you will see that that gets dramatically faster. Why I didn't just recompile it, I don't know. I always forget that we can just recompile Handmade Hero and have it replace the thing. But obviously it gets a lot faster if I compile it in release mode, but even so, you can see that that render ground cover is pretty significant there, right? It's more expensive even than gathering up all of the debug information that we spew into the log for processing, which used to be our biggest amount of time spent. So this right here, this render ground cover, as you can see, is like really, really expensive. And that's to be expected, but also something we could dramatically improve. So if you go to like the entity side of things here, and we look at how the render ground cover section, here it is. You look at how expensive the render ground cover section is, you can see why it's so slow. There's especially this part here, right, where we're getting these texture handles back. It's just really, you know, well, here, I can show you. Get assets. So, well, actually, I suppose that part's not that bad, because as long as it's valid, I guess it's probably okay. This is a bit fussy, so that's not great. But then if you look here, right, the amount of computations necessary for this stuff are kind of ridiculous, right? You can see we've got to go through all this nonsense here. There's this ridiculous garbage here, right? All of this stuff has to happen. And then we've got this stuff here. Again, just really ridiculous, just way too much code, right? And so all of this stuff here could have really have been cached. You know what I'm saying? Like, the only thing that we might not have been able to cache is the bitmap part of things, the texture handle part, because we're not, you know, we have to maybe make some extra affordances in our renderer for being able to say that I want you to not evict certain bitmaps because they're used in high volume scenarios or something like that, you know, shouldn't get thrown away until I can tell you definitively that I'm done with them. So there's definitely, like, you know, a bit of this that maybe can't be optimized away as much as it should be. But everything in here, like this entire section in here, all of that could be cached and would only have to update when the texture handle updated, right? And not only could it be cached in terms of not having to have the CPU compute it, but it could actually be cached on the graphics card, right? So all of the data that you would need for drawing the entire thing, all of that could just live on the graphics card, and we wouldn't have to do any of this, and we wouldn't have to send it down, right? So it's just worth recognizing that there's a ton of work we could do there as well, that we're just not doing right now. And so that's, again, we're in a good position. The part of our game that is slow in debug mode actually doesn't need to be slow anyway. We can improve it pretty dramatically, and that's pretty great. All right, but let's continue on with the lighting, because like I said, if we want to be fast, we can just compile in release mode right now, and we're very fast anyway. You know, we're hitting 60 frames a second, and not really any issues, I don't think. Although, well, there are some. The renderer does need to be optimized a little bit. You can see we're not quite hitting it reliably. We should be way under that, I think, probably most of the time. Although, I guess with VSync on, is VSync on or off right now? I don't actually know if VSync's on or off. We don't have a thing for that, do we? Let's take a look. So when we want to do our request vsync here, by default, it looks like it's requesting it. Now, why isn't that actually something that we provide for switching? Because you can, can't you? I don't know, maybe you can't. Let's see here. Not actually sure. So if I wanted to, can I turn VSync on and off? One more time. There we go. All right, so so it's a little bit hard to say. I'll be honest, I'm not sure I understand exactly what I'm seeing there. It might be that vsync, request vsync, is not actually, doesn't actually update when you change it there. That's what it looks like to me. It just seems really unlikely that that would actually happen. So let's take a look at that. Sorry to kind of get off track here, but I'm just curious. I want to know what's going on with there. So in here, we've got change to settings. And here's our platform OpenGL set vsync thing. So if we look at OpenGL set vsync, it looks like that should be calling the correct thing, but maybe it doesn't. I don't know. Let's take a look. So if I do platform OpenGL, if I basically set a breakpoint at this function, what happens? Looks like it's not getting called for some reason. Although that may just be that the breakpoint isn't triggering because of some kind of thing where it got optimized out. Let me just see what happens in a full debug build. Do we not call it there either? Okay. I do think so. I don't know. That does seem like maybe it's weird that didn't have a breakpoint set properly. I wonder if we should mention that to George, because it probably still should have set a breakpoint somewhere. But yeah. Anyway, let's see what happens here. So we're actually making the call properly. Vsync enabled should be true right now. So it's going to call wiggle swap interval x with a 1 there. So that's what that did. And now we just have to kind of see, okay, if I jump into the render settings and I ask it to change vsync, do I actually get in here? So vsync enabled there is 0, so it should pass 0. So it sure looks like we're setting it properly. I mean, it could be that, it's certainly possible that we are asking for vsync and getting it, and then asking for no vsync and getting it, but we just happen to take roughly a 60th of a second to render. But I don't know, man. Chances seem pretty low that would be the case. So we know that we're doing the right thing. Here's our frame time. It's, 118 roughly. Kind of has a hiccup in there based on the frame display. So that's happening. And then if I turn it to true, that seems like I don't know. That just seems like we're getting VSync no matter what we do, to me. So I guess I don't know why we're seeing that particular behavior. That's a bit strange. It may be that for some reason we're just not able to call wiggle swap interval, but I'm not sure why. Let's take a look at wiggle swap interval. I mean, it seems pretty straightforward. I don't know why that exactly would be failing. I don't know. So that's a bit of a puzzler. Because it looks as if we can't request no VSync. And I'm not really sure why. That may just be luck that that's happening, but I'm not sure. So we may want to put a to-do in here. I don't know if we've got the issue list. And I'm going to just put a note that we should figure this out at some point because something is off there. So I'm going to go ahead and do a new issue here. I'm going to say, are we actually able to turn off VSync? And I'm just going to say cursory inspection seems like we aren't able to turn off VSync. We need to look and see if there's a problem. So I don't know. Might not be anything. We may look at it later and determine that it's actually fine, but it does look a little bit wonky, so I just want to flag that as something we should take a look at. All right, back to light probes. So now what we've got, we know we were drawing in purple there where all the light probes, where we placed all of our light probes. And so now what we have to do is actually take those light probes and feed them forward into the renderer so that on any given frame, the renderer knows what light probes are actually in the mix and which light probes aren't, right? It needs to have some idea of what the light probes are or aren't. And what's interesting about that is if we go to the world cache, we've got this notion in here where you can see when we unpack entities, right? When we're doing our entity unpacking, we have this notion of entities coming into the working set, entities going out of the working set. And since our light probes themselves are entities, it seems like what we probably want to do here is start to think about the lighting solution as something we just want to manage as part of the world cache and uncache. So if you take a look at how it's currently working, it's kind of stupid, right? We have this entity structure, and and we knew it was stupid at the time, so not bad on us. It's just we were delaying till we were going to actually work on it. But you can see we got this ridiculous lighting nonsense in here as part of our cached entities. But we don't really need to do that anymore. What we can do instead is every time an entity gets unpacked that has that's one of our light probes, we can just add a light probe to the probe set in the lighting system. And every time an entity gets repacked that had a light probe, we can just pack that probe back up. And by pack it up, I don't actually mean pack it up. I guess I just mean discard it, because we don't need it anymore, right? It's gotten too far away to be relevant, right? So I think we should be okay with that. I don't know where my little basket is. Basket, come to me. Come to me, wastebasket. There we go. All right. So, I think that's more what we want to do. So I'm going to start down that road, and that'll be how our light probes like kind of work in terms of coming into or out of the active set. And then what we can do is, we know that if we render them as entities, we see them. We could do a secondary render that shows us not only where our lighting probe entities are, but where our light probes are, and we can verify that that's correct. So as things move in and out of the set, that we're getting a correct result there, right? So in here, where we have lighting point state with lighting here, like this, what I want to do is just start by eliminating this. So that's going to go away entirely. And one of the things about that going away entirely is that will pull a ton of code out of our system, right? It's going to go away. So now when we look at things like push light, right, and this sort of thing, the lighting point state, light store stuff, all of that is going to get yanked out. And the reason that it's going to get yanked out is because we no longer actually need this information to be present at all, right? Not sure what the right way to say this is. So the lighting point state was a cache of light information in the system, and we don't actually need that there, right? We do need to be able to push lights into the system, and we may want those lights to be special in some way. I don't know. But we don't need to have them have these caches anymore, because the light probes themselves will act as the caches, I guess is the right way to say it. This is actually really good for us because it eliminates a bunch of bookkeeping that had to happen during render time. And that bookkeeping is expensive, so getting rid of it will also sort of speed things up a little bit, if that makes sense. So I'm going to get rid of this and this. And we're just going to kind of slowly work our way through there. And, you know, this probably is a bit of a to-do here, where we're basically going to say, look, I don't actually know exactly what we want to do here. It's kind of a little bit confusing, but it's probably something like we want to just push a special purpose light probe in that emits this light. I don't really know. It may be that we to be honest, now I think about it, we probably don't want that. We probably want to keep a separate list of lights. They don't really need their data cached, so I think maybe we probably just need a separate list of lights per frame. That's probably what we want. So anyway, I'm going to get rid of this. Also, when we push cubes, pushing an emission value onto a cube probably is also something we don't really want to have happen anymore. So getting rid of that emissive value, I think probably we want. It's a little hard to say. I'm not really sure exactly how we want to deal with that part. Because we do want to be able to have emissive values, I guess, in a sense. So I guess I'm going to leave that in now that I think about it, because maybe that's actually fine. I don't know. We're going to leave that as an open question, but I'm not going to pull the emissive values yet. I am, however, going to also get rid of the lighting point state thing. So this nonsense here, that's going away. And I'll just eliminate it everywhere, because that'll generate errors for me in all the places that we're using it and so on. All right. Lighting box will also probably go away as well. So here's our lighting point state with our light store in it. That's going to go away there. All of this stuff where we're doing this push cube here, the lighting part of things needs to go away. So the lighting enabled stuff just goes away. So all of this, light count, light index, you can see how much code was in here too, right? Like, look at all this stuff. This is all going to go away. It's just going to be happening inside the pixel shader. The lookups will be happening there. So all of this stuff can sort of get cleaned up, and I like that a lot. Like I said, it's all good. It's very good. When we're pushing quads here, the emission for the quads... oops. Again, I don't think we actually want... What we really want to do is just when we put the cube down there, we just want to store the fact that this cube needed to be considered as part of the lighting system. But that's all we really needed it to do. And so that stuff goes away. I think also this emission value, when we push a quad down with an emission value there, I don't actually know that we need the quad to know about its emission value. It's possible that we do, but I'm not actually sure if we do or don't. So if we take a look at here, like where that emission's getting used at the moment, yeah, you can kind of see it's just not relevant, right? And I think we want to just get rid of this, because the quad, if you want to encode if you want to encode the emission value so that the quad just appears very bright, that might make sense, but gosh, I really don't know. Again, not really sure, so I'm just going to leave the emission in there. And the reason I say that is because although in here we don't really need the lighting value in that sense, meaning we don't actually need the quads to have any idea about lighting at all anymore. They're just render primitives, which is what we want, and that's good. But for a parameter like emission, when we have a quad that's supposed to light up, right? So this quad is supposed to be lit and bright. When that happens, we want the face itself not to like be shadowed or anything, right? It's emitting light. So we may need to encode into our like color values or something. We may need to encode the fact that this is not reflective. It's emissive with a certain level of emissive color. So even though this thing is not being used right now at all, I think I want to keep it in the pipe, because I think eventually we may need an additional value here, at least one floating point value, that just says how bright the quad should be of its own accord. So I think we can't get away with eliminating emission entirely. And so I'm going to leave that in there as a sort of proactive assumption that will have to change at some point for render clarity, right? All right, so looking at textured vertex here, we've got a bunch of stuff. We've got a normal per vertex that says it doesn't need to be per vertex. I don't know if I necessarily agree with that. We may bend that, so I'm going to actually get rid of that notion. These don't, but they're going away now. Light UV, not sure what that's supposed to be. Don't have any idea what that is. If we look in here at like things for lighting UV, I don't know. Does anyone use that? Nobody does. So who knows why that was there. So we're going to get rid of all that stuff. All that's gone. We're just going to have a point, a normal, a UV, and a color, which is a pretty standard layout for a vertex, and off you go. Okay, so, excuse me. So moving on, we've got the vertex to trim pointers here for textured vertices that are sending down those light indexes. We don't want that anymore, so that's going to go away. Again, just pulling stuff out of the pipeline here. Those don't need to get sent down at all. Similarly, when we're doing our push quads here, anybody who was passing through light information, that can go away as well. Let's take a look at the debug light store here. Okay, so in here where we're storing this light for our debug light, again, that doesn't need to be there either, because again, those things don't have to get cached anymore. You can kind of see that assuming we're able to make all this work, getting rid of all this code is also great, right? This is all code that was costing us time before, and now we don't have it, right? So that's all very good. Oops. So hopefully, you know, that's all like gonna be a plus. Again, just pulling out the vestigial remains there. You can kind of see in here we've got the storage for our, you know, where we were putting the information. We don't need that stuff anymore. That's just blending the old light solution in, so again, get rid of that. And this stuff is all going to get nuked anyway. Where's our lighting point state? There it is. So when we're doing this sort of like, yeah, this part where we're working the lighting point states back up again, don't actually need this for anything. So I'm going to just walk through here and pull it out. So box store direction. So the problem with this code is we may want this rough code because we are going to be updating, like we may want to keep how this is sort of working a little bit. So I think what I'm going to do right now is I'm just going to if zero this guy because I may want to look at this code later when we implement the frame-to-frame coherence of the new system. So I don't really want to get rid of it just yet, right? Okay, so let's see here. Here we've got our lighting push. Again, that's pushing on stuff it doesn't need to. Same with here. So I'm just gonna get rid of those and leave them like this. And that, again, just cleaned out like a ton of stuff, right? Which is good. Same here. We don't need this. Don't know where else we might have code of that nature. Some push cube stuff. That doesn't do lighting. So there we go. And so now, again, that sort of pulls the lighting out of that sort of specific part of the code and allows it to just run directly. Now, inside the actual renderer, we need to pull out the part where we're actually doing that lighting as well. So if I go and look at the Z-Bias program, and we look at what we're actually doing in there, I want to get rid of the things that expect to receive that. So the vert light index and the texture where is it? Well, I guess only the vert light index is getting passed on. I don't know exactly what's going on there. But the vert light index can go away, and so the frag light index can also go away. Those two things wouldn't be passed down anymore. And so where that was getting sort of sent through, we can just get rid of it, right? And then inside the actual sampler here, we don't need the light 0 sampler or the light 1 sampler anymore, but we're going to leave those in temporarily. Going to get rid of the frag light index. And so in here, I think all that stuff gets ifed out on lighting enabled. You can see here, this was the part we would have been looking at that frag index and doing something. And so now we don't have to worry about that, right? And so here we're doing our texel fetches from the light information. We're going to want to keep that. So I'm going to do an if lighting disabled here, and then I'm going to do an else, and I'm just going to get rid of all of this stuff. And we know that lighting is, in fact, disabled at the moment. You can see it here. So I think we're okay mostly with what we're doing now. But we may have to fix some errors in the shader, right? So it'll report those to us. OpenGL will, or should. Okay. So we're almost there, but you can see we're missing our quads. And so we probably have some vertex alignment issues or something. Who knows what we've got. But we'll hunt it down. So in here, we're not doing lighting, so we wouldn't expect there to be any problems with that in the shader, but let me just make sure that we don't have any of that. Oh, you know what I just realized? Actually, this was our problem here. We still need this texture index, right? So I accidentally removed that one, but we still want that one, right? So I was just being a little bit overzealous there and forgot about that part of it. But inside the textured vertex, yeah, we do need this just to tell it which texture to grab. So there is, I guess, still a thing that's, we don't really need to send this down every time, right? If we have a quad that consists of 4 vertices, actually we only need to tell the graphics card once which texture index it is, because you can't change texture indices per pixel. I mean, we could, but why would we? It literally doesn't do anything for us. So we're just kind of wasting space at that point, which kind of sucks. This does bring up one particularly interesting option for us. You can see this vertex is highly unbalanced at this point. It would be 16 bits off. But, as we already said, right? We could put some emission in there. Right? Probably not. That would have to be per pixel, so I don't know. So we know we at least would like an emission level, right? And it could be a 16-bit emission level if we really want to. And so that's kind of a cool option to sort of pack in there. We basically have 16 bits that we probably want to use up just to make this thing be 4 byte aligned. So I feel like that's a pretty clear option of where the emission would go. Maybe we want something else in there too, but I don't know at this point. All right. Let's see how we're doing there. Oh, I gotta go re-if out that part of the shader though too. Sorry about that. So like I said, we do want those texture indices to be sent down. And then in the ZBias program, I want to make sure that lighting disabled stuff is still lighting disabled. So this frag light index here, doesn't need to be there. The same thing is true in the shader itself. So that frag light index goes away. I'm going to go ahead and put the if lighting disabled in here, else, and then this whole part can also go away. There we go. And then this part should already have the lighting be completely disabled, which is what we want. So I think we're pretty good here. Okay. So now we just have to fix whatever bug we introduced here, where we're, you can see what's interesting about this is you can see that for some reason, solid cubes are working. So it's only things with a texture on them that aren't. So I'm not sure if I did something weird there with the texel fetch. But I don't think so. So the frag texture index that's coming in there, the invert texture index there. Oh, you know what? It may have been that I forgot to delete that reference to the in. That could have been it, actually. Nope. So we're still getting some kind of a problem where the texture, probably with the texture index, is not lined up properly or something, right? So let's take a look at what happens in that code and just see if there was something weird going on there. We should just get rid of this light index nonsense here, the vert light index stuff. So I'm going to go into the prog system there, not Prague the city, but Prague the structure. So we've got this vert light index. I'm going to delete that because it might be that someone's using that and we're creating an issue, right? Like this, for example. So I want to make sure that that's not happening anywhere. And that's completely removed. Like this. There we go. And I don't know if there's anywhere else we might need to fuss with it. We'll see in a second here. But just kind of start to trim these away. And then what we can do is we can open up Nsight and take a look at what we're sending down. Just make sure that we've got everything before we start a little more hardcore debugging to find out what went wrong there. But we're mostly good now, I think. Just got to figure out where we lost our texture index there. I'm going to scan this really quickly. And I would like it to not be behind my head. So just looking through here at vert texture index, it all seems pretty good. I'm not seeing anything weird. The lighting stuff is all more or less gone. That all seems fine. So that all seems fine. You can see here the sampling from the frag texture index, which is set there. But oh, you know what I just realized? When I was being overzealous there, I probably forgot to fill out the texture index. Yeah. So you can see here, I totally did, right? You can see here that we're just not filling it out. So this is supposed to have a texture index, right? And I totally got rid of it, right? Because every time you do this, you're, when you call write quad, you're supposed to be writing the quad with a particular texture index in mind, and I just totally got rid of it. Let me just verify that that's true, but I'm pretty sure that's what we did, right? Yeah. So that's just stupid. I don't know why I did that. But again, I think I was just for some reason thinking there were 2 lighting indexes for every vertex. I don't know why I thought that, but in my head, like I was just being too crazy with it. I'm not sure why. That's just what happens sometimes. All right. So in here, this code is, for whatever reason, I don't think we're actually calling it though, right? So it's actually the other one, like the other code, I think, that was the problem there. But you can see here, like write quad was supposed to be called by somebody and never was. Right? I don't know if we thought we were going to speed something up and then didn't. I'm not sure. But push quad, which is the one we actually call, this one here, push quad is going to have the same problem, right? So we probably get the texture index we're supposed to use, and then, yeah, you can see we never actually fill it out here, right? And if you look, we never passed it down, so it's not as big of a piping problem as we had in the other one where I accidentally deleted it from being passed in. But basically in here, we've already got the texture index right there. We're just not filling it out. So that's just a case of, again, overzealous deletion. We still do need that, even though we would prefer to not actually need it and to have done it per primitive. In this case, we can't do that yet because we haven't ever set up a per primitive thing for our quads. So now we hopefully are piping that through properly, which means our vertices actually correctly have their texture in them. And it looks like that was the only thing we were missing. So now that lighting stuff has been pulled out of the lighting path entirely, right? And so we should be good to go here now. What we need to do inside the shader, of course, now is we need to sort of pull, excuse me, inside the actual pixel shader, we need to pull from the lighting probes that are inside the voxel, right? And so we want to have some way of doing all those lookups. I don't know how much time we have, but it occurs to me that maybe I could do this in the opposite order we thought we were going to do it in, meaning I could, if we wanted to, actually not do the light propagation first. I could do the lookups first and go from there. Now, I don't know if that's actually something we want to do, but it's certainly something we could do, right? And so, meaning I could send down light probes that are fake. We just set them to whatever we want. And then verify that the pixel shader actually pulls from it correctly, right? And so that would be an interesting thing to do. I don't know if we want to do it that way, but we certainly could. So let's think. I think I still want to do the light probe pushing pass first. That still seems a bit better to me. And in terms of lights themselves, that part is a little bit more squinky, and so I'm not sure. That part's a little harder to say. Anyway, I'm going to go to render commands here. And if we take a look at what we're keeping track of, my question is just like, how do we want to get these light probes pass down to the lighting system, right? So if you look at what's going on in here, you can kind of see that the push buffers for our game render commands, the lighting information actually doesn't get pushed on there, right? You can see this pretty much just takes quads, and that's the end of it, right? There's the index array, there's the texture array, and there's the vertex array. So all of that stuff moving down through the system there makes good sense. When we were pushing lights in here, right, what we were sort of expecting to do, I believe, and let me just take a look at the render group. Yeah. So what we were expecting to do is sort of push lights on separately as part of this pass here, right? And we've got two sets of things we need to send down. We need to send down the boxes that are used for collision, like raycasting, right? So that we can track what's hitting rays and what's not. And then we also need to track where the lights are that are actually flooding in emission to the scene, because those are, you know, again, also something we want to keep track of. So if we look, I guess what I would say here is we can probably keep this pretty similar and just sort of change lighting box So I guess the thing that I'm not sure exactly how we want to do it. Yeah, I'm not sure exactly what we want to do here, but I think we want to keep this stuff relatively the same. The only thing I'm thinking is that maybe emission wants to be a separate thing. Like, we want our lights themselves to be stored separately, but otherwise this looks fine. The light index 7 part of things, that part I want to look at a little more closely. So let's look at where that's being used. If I compile right now with that out, who actually gets upset with me? Yeah. So those light indices were just where we were storing light information for the faces of the cube, which at this point we're not doing anymore. Those are going into our light probes. So the things that we actually hit and bounce light around on, those are actually not, it doesn't matter, right? We're going to gather the lighting from the probes at that point. So I think that just goes away. It's just not a thing, right? So if we take a look at that lighting box, that doesn't need to be there. Now the child part of things probably does, because when we do our lighting box computations, we're still going to need a spatial hierarchy. And so I feel like the thing we use to like build up the boxes, we're probably still going to need for raycasting, would be my guess. I don't know that that's true. It may be that brute forcing it actually would be better, given how few of these boxes there actually are. But I don't want to pull out code that I don't know if I need. So for the moment, I'm going to say we'll leave these two in there. Transparency, I don't know what to make of that. I don't know that we really want to model transparency inside the light convection. I'm assuming that if I get rid of that, nobody complains, because I don't think anyone was probably using it. That transparency just wasn't actually used in here. So I'm going to get rid of that. I'm not going to have that be recorded, and we're just not even going to pretend that we're going to do anything with it. So I think we're down to just this stuff. I think this is pretty accurate with what we would need. And then these two pieces of information here, we're going to leave on there because they are part of the spatial hierarchy thing. But because all of the actual reflectors themselves, which are at the base of the hierarchy, don't need a child count or a first child index, I'm not 100% sure we actually want to put them there, because we may want our spatial hierarchy to just be something else that has nothing to do with these lighting box structures themselves. That's sort of a separate issue, and we can take that up a little bit later on. So we'll see. I don't know where that's going to go exactly, but we'll sort of play that by ear. In terms of emission, I don't know what we want to do about that, but I think emission itself is probably something that we would want to, like I said, I think we might want to put lights in a separate list so that we're not really looking at them like this, but I don't know. So that's something we'll have to think about a little bit more carefully as we go further down, as we sort of get deeper into the system. All right, so let's take a look at this lighting index nonsense. This stuff I don't think we need at all. So this extended light point count and the light indices, I don't think any of that stuff is important. So I'm just going to get rid of that. Yeah, and I don't really care about any of this stuff at all. So basically what we're going to do is we're just going to get rid of the accumulated light information here. So this stuff here where we were kind of, where we were doing that, that's just going to go away. And what we could do is use the actual, like when we're doing the ref C here, we could do something a little bit more specific with it. But I think what I'd rather do, just trying to think, for the child indices, yeah, so what we could do for that is just say where we get the ref C there, yeah, none of this stuff needs to happen. Where we get the ref C there, we could just sum up just from the children, right? So I'm not really sure how that wants to do its thing. But it seems to me like it maybe wants to do this. I'm not sure. But basically like the length difference here, I suppose, oops, yeah, like the point, we don't really care about the point. We just care about where the lighting box itself is. Did that stuff already get set in a different pass, by the way? I'm not sure. You know what? I don't really want any of this stuff, so I feel like I just want this stuff to go away. And later we can sort of figure out how we want that stuff to propagate down, but I'm just going to get rid of this stuff. We don't want this stuff at all. Right? Let's just nuke it. All right. So here where we actually, in here we're doing the, looks like we're doing the thing that actually builds the box surfaces here. And again, I don't think I want any of this stuff, really. This is again for sort of treating the boxes as if they were things that we reflect around, but we're not really going to want to do that. So I think this stuff is just not, yeah, just not on the table. So I'm going to go ahead and get rid of that. Here we have, this is just the lighting output here. It looks like this was stuff for, you know, I'm not sure what this was stuff for. Oh, right. So this is just stuff for storing the averages over time. All I really need to do there is just, again, if def a little bit more of it out. I wanted to look at this code because our averaging seemed to be working pretty well. And since that's a fairly fuzzy thing to do, I wanted to be able to reference what we were doing already. All right. So as far as lighting point output goes, yeah, so like this stuff here where we're looping over these, again, this is, I'm just going to go ahead and if zero this out, where we're outputting this lighting because we're going to be outputting probes instead, and so it's going to be pretty different by comparison. So I'm just going to go ahead and do that. Okay. So we're now still sort of technically doing some stuff with the lighting in there, but it's not stuff that is meaningful anymore, right? So we kind of nerfed it. And now we can start to build the actual lighting probe system on top of that. And we still have, I think, we are still going to be able to have the, where we put these lighting boxes that are used for computation, we're going to still be pushing these down. We're just going to be pushing them down without the sort of light information in them. It's just they're there as blocks to sort of take rays that hit them and stop those rays from propagating, right? So it's the collision geometry for our raycaster, but that's all. And so that's sort of what we've pulled out is the part where the lighting information was welded into them, which we didn't want. So when we actually do a push cube here, what we want to do is say, whenever you're doing a push cube, whoever pushes the cube, if the lighting was enabled, we push just the cube data onto the lighting system, right? So basically what we say here is if group lighting enabled, then what we want to do is in that render group, we've still got this idea that the lighting boxes get pushed on here. So we would say, all right, give me a lighting box I can fill out. Interestingly enough, I suppose even this could work with the entity cache. Because we could actually do a thing where we just don't even have to build the spatial hierarchy every frame. Like if you think about it, we could just insert and remove things from the spatial hierarchy. That tends to be hard. Incrementally updating spatial hierarchies is a lot of work. So I don't know if we really want to do it, but it's worth noting that like we sort of could, because we now know when entities come into and out of that cache. It's worth thinking about. Anyway, In here we've got the lighting box. We need to grab that from the render group where it should be. And so that would be in light boxes plus whichever one we're on right now. So light box count, right? And before we do that, we just want to assert that we haven't blown out the total list. So we want to assert that that light box count is less than the maximum. So somewhere in there, we've got a maximum light box count. Although, I guess I don't know where. Let's take a look. So we push light data width's worth of light boxes on. That doesn't really make any sense anymore. So I think we kind of want that to be a different piece of information. The reason I say that is because our reflection geometry is no longer coupled with our lighting output, the number of light probes we take. So we really just want like a light box, like a max light box count kind of a thing, right? And so this right here, which is would be the number of light probes, is going to probably reduce dramatically. And this max light box count here is now what we're using for our actual to determine what the maximum number of actual colliders we can have for our raycast, right? So it's pretty different than the old system used to be, where those two things were locked together. So if we take a look at our light boxes now, when we get one of those out, we don't need to fill out hardly as much information as we used to. It's a lot simpler than it was. If we go back to the lighting box and we look at what goes in there now, we just have like the child count probably has to get initialized to 0, but that box P is just going to be the actual location. The box radius is just going to be the actual radius. And the ref P, this is a bit of an issue. The ref P actually needs a little more information than it quite has. The renderer texture in question, we kind of would like to have sampled from that texture. That's kind of the crazy part, right? Is that when we're doing this sort of raycasting, we almost want the cubes themselves to have an additional color that's information about it that lets us know how we want to bounce that light around. And that would normally, we would want that to come from this particular, from this texture, right? And so we sort of have a latent to do in here, which is that the texture should have the information in it about what its reflectivity is and currently doesn't. And so that's a little bit of an issue. If we go to renderer texture, we have an index in there that tells us which index it is on the graphics card. And what we probably need to do is have the asset system also be able to look up the general reflectivity of whatever that texture is. So I'm going to just proactively say, because I can and am going to, that we're going to store the texture index into the lighting box structure now, so that we can add texture lookups in there in a sane way. If I just imagine this happening, right, that would store the information in question. So I'm going to go ahead and do that as well. And that's just this, right? All right, so the reference color can just get passed down as the actual color. The emission is the emission. And then that's the full thing. Like, there's nothing else to fill out. We can get rid of the first child index as well, but we don't really need to, so it's unclear to what extent this actually has to happen. These here, all of that stuff is probably fine. Let's see, we missed one. Color, we just need that. All right, so now we're sending down the light boxes, and presumably the system can still continue to function pretty much the way that it was. And we can still raycast against those light boxes. The only difference now is that when we raycast against those light boxes, we're not storing the information anywhere. Like we're not actually doing anything with it, right? Like if we go back and look at the lighting system, when we actually were doing the light propagation, which is here, if we actually re-enabled the compute light propagation stuff, oops, that's not the one I was talking about. That's not the worker thread. Where's the worker thread? Here it is. So when we were actually calling this, what you can see here is what we do when we actually, we cast a ray. What we actually do when we cast these rays is the result of the rays was getting distributed out to the lighting points that from whence we emanated the ray, right? We're basically doing like a transfer, an energy transfer there. And that stuff just wants to go away entirely, right? We just don't want, like this surface point stuff just needs to go away entirely. And what we'd like to do is we'd like to have this ray tracing process have built into it that it's sampling from a particular point of the light probe. Like every ray has a destination it's supposed to write back to, and when it hits something, it just writes it back to the correct location. And again, that's why I said I think we can speed things up as well, because once we once we're actually using boxes more intelligently, we shouldn't have to worry about that that finickiness of like which point specifically we were looking at, right? So that's one thing. Another thing we could consider doing here, and I do think this maybe would make things easier for us, is if you take a look at what happens here, look at how much work we're doing for looking up box surface indexes on collision, right? And so if the textures actually got, like, let's suppose like in here, when the textures are getting rolled in here, if instead we just said the color of the box here, we pre-compute what the texture modulated box color is, and we just use one color per box, right? So we don't store colors for each side of the cube. That seems kind of compelling, right? That way when we do our hit test, this crap doesn't have to happen, right? There's just a lot of work going on here, you know? And I really don't know if we need that to happen. Now, we do have one problem, which is when you're raycasting against boxes, you do have to figure out which side of the box you hit, right? And we could argue that maybe what we want is not really boxes, but we actually want our quads to just be the primitives we ray trace against. But I don't think so, because I think that's going to be more expensive. So it is true that, yeah, in general, I suppose, when we're looking at our masking operations there, it does kind of look like, you know, this box surface index, this part here, we could save that, and that does save 3 instructions from each of those passes, right? Although looking at it here, that mask does the selection. Actually, it looks like I'm wrong about that. It looks like actually we can remove the whole thing, because it looks like we only update the distance, based on a select with mask, which we already computed. So again, yeah, like if we were to do this, right, all of that computation would go away. Like all of that. And that's pretty compelling because that is a huge amount of work on every ray hit that we would no longer have to do. You know what I'm saying? So that's pretty compelling. That feels pretty compelling to me. That feels pretty compelling to me. That seems like that saves a lot of time, right? And since, you know, basically all we would have to do for that is just say, look, boxes just have one color. So if you want higher fidelity lighting than that, you got to add more than one box, right? Which you could do if you want to. You can break a single cube up into multiple sub boxes that have different colors in different locations. You could do that. And I think for most of the time, since you're usually only bouncing lighting in an important way off of one of the faces, it usually like is used to create like the world, and I don't know that we really need to do much more than that. So I'm thinking that probably should get removed. And box surface index, which, you know, is the stuff that needs to sort of operate off of all of this. That seems like something we would like to just get rid of. So that's good. I mean, that would really pretty dramatically reduce that count there. I don't know why this is still compiled in like this should be an if developer kind of a thing for sure. But that looks pretty good. I mean, that looks like it saves a tremendous number of operations from every ray hit. Now, granted, it doesn't really save any operations in the case where you were testing a root or a interior node, a non-terminal. So when we're walking the bounding hierarchy, it doesn't really help us because we never get to that part. We weren't looking at which face of a cube you hit when you had children that you should have gotten down to a lower level of. So it doesn't really speed that up, but it does speed up the case where you were hitting boxes at the low level, and since the lowest level of the tree is where most of the boxes are, that's probably nothing to sneeze at, right? There probably was a lot of time being spent in this box surface index retrieval, or computation, I should say. So yeah, you know, I'm gonna say that's possibly good, possibly important. Yeah, I'm gonna say that's pretty good. Now, one of the things I'm not 100% sure about when I'm looking at this code is we do say in there if all of the, so that you can see this line of code here, it says if all of the mask values are true. That means if every ray, this is a packet tracer, right? So it's tracing 4 rays at a time. If all of the 4 rays that it's tracing at a time all were, I guess, further away, let's see. T valid and T min is less than result T ray. No, sorry. They're all closer. So if all of the rays in the entire packet hit this box, I guess, then it stops looping. But I don't understand why. Like, is that actually valid or is that just a bug? I don't see it. Do you guys see it? So we have a ray origin and a ray direction coming in here, and we're basically telling this thing, here's the lighting work structure, right? We're basically telling this thing, hey, we've got a stack of boxes here, and we're taking a box off of the stack, and we're going to test all of that box's children. So we loop through the children, right? I mean, this is what we're fundamentally doing. And we've got a mask that we're testing here to see whether we can stop considering children. So what are we, like, how are we making the determination that we don't need to test any more of the children here? We're looking to see whether or not the hit value, right? Whether the hit value is valid and less than the closest hit. And I just don't see why that would be a termination condition. I could see, okay, so like if I don't see it. Look, you have to test all the children, right? I mean, I don't see how you cannot. It just doesn't make any sense. I mean, does anyone out there, I guess I'll ask the chat. I have a box. It's got some number of children inside of it. When I'm hit testing, I don't have any real way of knowing those children in there aren't sorted in any other way, right? They're just boxes that are inside this box. So I don't know, and I'm not like sorting them by the ray direction or something in here, so I don't even know which direction I'm passing through this box. So I can't know when I'm done testing children, because the children could have been anywhere. So just because I had all of the rays hit one of these things, why does that stop the traversal? Anyone? Is this just a bug that we've had in the lighting system? Anyone in chat? Am I being stupid here? But I don't think I am. I think that's just wrong. Because I don't see how you could stop iterating over the children of the box until you've tested all of them. They all might fail. I'm sorry, they all might produce a better hit. So any hit that you have might not be the closest. And at that point, you're kind of in a situation where you're not returning an accurate lighting result here. So saying that everything is true in the mask, so what? Like, why does that doesn't help you? Like, I don't see how that helps you at all. That just seems like garbage. I'm going to put a to-do on this. But this is just going to have to go away entirely. And in terms of total partition leaves used, I assume we might as well still track that piece of information because, you know, if we were trying to count, that is accurate, right? But I don't understand why that was in there, and I also don't understand why, like, I don't understand why this was only counted during an all true case, because the total number of partition leaves that you used is actually 100% dependent on any one of those lanes. You used the partition if any of the lanes hit. It doesn't matter if you only hit in one. You don't have to hit in all four to use the partition lead. So this code just looks like complete crap. And I think we just had a bug in there, which probably contributed to our noise. So that's not good. Like, that was not good. I'm pretty sure that was a bad situation that shouldn't have been happening. I'm pretty sure. But we'll see when the VODs go up for this and some people take a closer look at it. You know, maybe someone will be like, no, go back to when you implemented it here, you had a good reason and it works okay. I'm like, all right. But that looks like crap to me. There probably are ways you can early out of this loop, but they're probably not related to that. Because they would have to have something to do with whether or not you could determine definitively that you were never going to hit another box earlier than this box. Like, for example, if you determined that the hits were all at the min value of the parent cube, then you would know that no other child could have been closer anyway. And so that's an early out condition that would be valid. I don't think it's one that would happen very often, so I'm pretty sure you don't really care. But, if we had been testing that, I would have said sure. But we're not. We're testing just strictly whether or not we've got hits. And hits are not really dispositive in this case, so that doesn't seem useful. So anyway, if we were to assume, going back to what we were actually working on here, if we were to assume that we were to eliminate the box surface index, and so the only thing that we really know when we get back a raycast result is which box index it was, when we hit it, and if we hit it, right? That's a more sane way to do the raycast. What I don't necessarily know, as far as the box surface index part of things goes, is when we do this raycast, do we actually care about that? Or do we just want to know what the color was, right? Do we actually need to store a box index here, or can we just send back a color value, like an RGB, and use that? right? Um, and it may be that it's just more efficient to like return back the index, but I don't think that it is because that index is like a split lookup thing that has to happen, which is not great. You know what I mean? And so I kind of think that, modifying this raycast, it would be nice to sort of change it to something where it's like, if the raycast never needs, I'm just going to look at who calls it. If the raycast never actually needs the sampling out of it, so this is, all right, so first of all, this is the only place we call it. So if this thing never needed to do all this garbage, right? This is really expensive and it's crap, right? And the reason that it had to happen was because we were casting off of boxes and we had to see like when we hit a box, we had to see like what the color was at that point on the box. We don't really want to do that anymore, so I'm imagining that probably the right thing to do is to do the right. We what we want to do here, right, is we want to do the lookup of the, okay, yeah, as I'm saying it I can kind of see why this is a problem. So we definitely don't need to send back the box index, I don't think. All we need to know is the point. So we just need to know the location where we hit. And we already have that, it's this, right? So then what we actually do need to do is, based on that position, we then do need to do our indexing into the voxel and to produce the averaged color based on light probes. So we do actually need to know at that point, when we shade that location on the surface, we would need to know that. So we do need to know a normal, I guess, as well, if we're trying to shade from that surface. And so, although we don't need to record the box surface index, one nasty part is that does mean we may need to still do a little bit of work to determine which direction we were facing. So I think we may need that, unfortunately, as much as I wish we didn't. And so if we go back here and take a look at that piece of the code, right? You can see in here where we're sort of like, all right, this was how we were assembling the box surface index before. The question is there any way that we can get, without having to go through all of that garbage, that we can get the shading normal out of it, right? And you can kind of see here where we've produced the information for the hit. We did it by kind of going through and selecting Ugh. So when we kind of come through here, the problem that we're going to end up with, the problem that we end up having, is we do want just the normal to be stored. And we don't really want to have, like, this information tells us which box surface we were on. So obviously that would tell you the normal. But it would be nice if we could figure out a way to get the normal out better, right? Something that didn't require as much work. Because you can look at here, when we determine whether or not we hit the box, just using that tmin tmax value there, it feels like there should be some way of doing the same process. You know what I mean? We create the T-box min and T-box max by taking the ray direction and figuring out how far we have to go to hit the close side of the box and how far we have to go to hit the far side of the box, right? And then using min and max, we determine which one of those will occur first and second. You know, that's all we're doing. I guess what we could say, this is a tough one. I guess what we could say is that the comparison between T-box min and T-box max would tell us which one of those two we were doing. And then we're going to have to work out some math for this one. I think this might have to wait until next weekend. But I'm just thinking about it, and I'm like, it feels like we should be able to get that directly, so that when we get a true hit here, it feels like we should be able to do something here that allows us to compute this without actually having to compute the index of which face was hit. You know what I mean? It feels to me like there's some way we can do that. And if you think about it, we know, because we know, like, we can do this comparison ourselves if we want to, right? Meaning we still have T-box min, T-box max, right? So we can do this comparison. We can say, produce a mask for me that tells me where you picked the minimum and where you picked the maximum, right? You know, which lanes hit on the min and which lanes hit on the max. When I know whether you hit the min or the max, right? When I know which one you did, then I know I have information about where the ray was coming relative to the box. So I know whether it's hitting a min side, so a negative facing normal. Like if you hit the T-box min, right, then it's a negative facing normal. If you hit the T-box max, it's a positive facing normal, right? So I know whether it's a +1 or a -1 just by this, I think. And so then the only question is, which of the three sides was the one that you hit? Was it X, Y, or Z? And so how are we determining that here? Okay. So it's this process here that's determining that, right? Whether X, Y, or Z was least. That's what's determining it. Full stop. So, in theory, at least, in theory, it would look something like this. So tmin equals tmin.x me just double check my assumptions here. So the team in here, right, which of these three it equals, that tells you which axis it is, right? And then whether or not this right here, that would tell you whether it was positive or negative. So with those four comparisons, you definitely have all of the information you need. And so you could use a select at that point to produce the normal by doing four comparisons and a bunch of selects on the results of the comparisons. That might still not really be what you want, but it's a start. And it is cheaper than all of this, probably substantially, actually. Because first of all, none of this is serially dependent, so all those can issue at the same time. And then you can, the select, you're only going to select that normal. So if we go look here, right, that normal, you're setting four of those, the X, the Y, and the Z, sort of separately. This F32 4X of the normal, it's really a Vec3, right? So it's really a V3 4X that we're talking about there. It's this. You know what I mean? So if we were to actually be doing the normal there, then presumably we can set each lane of the normal as a select itself. So I think it might be something close to as simple as this. So when we do the positive or negative part of things, right, we're going to figure out which one of those it actually is. This is sort of a separate thing. It's like the positive or the normal sign, right? Something like that. And the normal sign is just a flip between like 1 and -1. So it's really just like, look, it's 1 if the min was less than the max, then it's -1. You know what I'm saying? So we would determine the sign of the normal here, and then in each of these, I think you just select between the 0 value, so there's nothing in that channel, or the sign value if it is actually the thing that's in that channel. Oops. So I think it's this, or close to this, right? Which is to say that we need 4 tests and 4 selects, which is a lot cheaper than this probably, I think. Because this has, you know, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I mean, there's probably 30 plus instructions in there. And this would be like 8 if you have select, like more like 12 if you don't on the platform. So I think that's a pretty significant savings. This could probably be done better though. All right, so I'm going to leave that temporarily. And yeah, I don't know if we have like a 1 or a -1 in here anywhere. So we have a 0. It's just that. So that's fine. So I can actually just do this, I suppose. I guess another way to say that would be it's just an and, because when it ands, it'll just and out to 0. So I guess we don't need to select, because if you happen to select with 0, you're in a good place. So you should be able to actually do this, I think. That actually makes it even cheaper. Oops. Right, so that's the actual value that we'd be selecting. And I guess since we have to mask these in here, though, I guess we do have to do this. So it is a little more expensive than I'm claiming, or was thinking, right? Because you do have to do the select in there. So it's only really 2 instructions to compute the value, but you do have to select in, which is kind of annoying. Selections are cheap on some platforms. On more modern CPUs, they're very inexpensive, but on older CPUs, they become less expensive. They become more expensive because they don't actually have an instruction to do it. So it becomes multiple instructions. It's 2 ands and an or usually. So one and not, one or and one and kind of a thing. It's not great. So anyway, yeah, looking at this, I think this means it's 4 selects, 4 comparisons, 3 ands. Not great. We might be able to get it down less than that, though. And, you know, we'll see. But I think we do have to do it that way. And that selecting is annoying, but I think that's just how it has to go. All right, I'm going to leave it at that. We don't have a 1 and a -1 in here. So I think I'll just make one. For now. And that can be that. What is select complaining about, though, here? I'm not actually sure what it's grumpy about. I mean, that looks pretty reasonable, right? But it doesn't like it. Another 2 layers compute there could be v34x. What does select want? It's a f32, f32, f32. It's trying to f32, v32. What? I see. I see. So we probably want more like that. Let's take a look. Is that actually going to be accurate, though? So when we did these comparisons, we then took the minimum of those two to produce tmin3 and tmax3, and then we collapsed them down. So the problem there is, again, yeah, we don't know which one we used. So we need to go back and figure out which one we used there. And ugh, yeah. All right. We're going to have to do this next time. This is going to be pretty complicated. I think we can do a good job on it, but figuring out that normal is going to take us some work. Let's go to a brief Q&A here. That's going to be annoying. We're going to have to work that one out on the blackboard, by the way. Do you have any tips for how someone would go about moving an existing code base from object-oriented programming, assuming you're in control of it? By the way, thank you very much for the series. I'm learning so much that $15 doesn't even begin to compare with the value you're providing. The fact the series is free is even more awesome. Oh, well, thank you very much. I guess what I would say is moving an existing code base from object-oriented programming to, for lack of a better term, programming, usually involves a couple different things you have to do. I would say you probably want to start by looking at the objects in the system and their member functions. And I would start picking apart the places where people have placed member functions into objects that clearly shouldn't be member functions. There's usually a lot of these. Typically, so just to be clear, you've got two sort of competing ideas. There's the concept that someone is doing something to data, right? So I'm going through a list of instructions I should do to my data. You know, move it over here, add 3 to it, do whatever, right? And that's procedural. And then over here you have a different idea, which is that data does something to itself, and you are just asking it to do something to itself. And that's object-oriented programming, right? So the problem is when you're thinking about the object-oriented programming, and this is especially bad if the people who do the object-oriented programming are particularly far down the rat hole, what they'll do is they break up a single procedural notion, which is here's the things I wanted to do in the order I wanted to do them in, into like tens or hundreds, or sometimes if you're really unfortunate, like 1,000 little functions each on an object, and they all sort of conspire to do this one thing that was actually pretty clear before. So what you want to start doing is going, where can I start to pull out procedural things that happen in this code base and remove all those little weird like member functions that do tiny bits of things, and how can I pull them into coherent single procedural blocks that do an operation? That's the first thing I would start with, trying to highlight the places where I can create real procedures that capture the meaning of the program properly, and disaggregate those from the objects. That'd be the start, right? And as you turn that crank and focus on doing that more and more, your objects should start to become just structs, and then you can start to think about merging them as necessary or splitting them as necessary into smaller data chunks or larger data chunks as is dictated by the procedural code. That's probably what I'd say. Solid Gaming asks, I'm only on episode 81, so excuse the newbiness. I've created different modules in my code that store different data for my entities, physics, render, AI, etc. Would it be silly to create an anonymous module type that unions these different modules into one generic struct, meaning I can put them all into one array and pass it around? No, that is not at all silly. So, in general, what you have to remember is like polymorphism in the object-oriented world, is how they say that, is just one flavor of a broader concept, which actually has very little to do with object-oriented programming and has more to do with code reuse. when a CPU goes to execute a particular piece of code, that code always has to be the same. So when I create a chunk of compiled code in my program, it's going to execute the same. And the question is, how much leverage can I get out of that one piece of code, right? Because there's reasons I might want to do that. First of all, code has a cost. It has to be decoded. It has to live in a cache somewhere. It costs me to execute code. I don't want an arbitrarily large amount of code, right? But also, it's less things to write. If I can write one little CPU routine to do a bunch of things, and I reuse it a bunch of times, hey, that's good on me. I didn't have to write too much code, right? And so sometimes what you would like to do is reuse a piece of CPU code to do two different things, because those two things are closely related. And so one thing you might want to do, for example, is reuse like some allocation. And this can have benefits even beyond just reusing CPU code. It's also reusing memory potentially, right? So sometimes what you want to do is say, look, I've got two things. They're actually totally different, but I want to treat them the same in some parts of the code, so I'm just going to union them together. That means that when I create one of these things, I can use it as either thing, and just depending on who uses it later down the pipeline, they're going to decide what to do with it in one way or another, right? That can pay dividends by not only compressing the code down so that you have less code necessary to do the same operations, but also it allows you to avoid things like memory fragmentation. Because it means if like one of those things was 6 bytes larger than the other one, it doesn't matter, right? You're wasting a little bit of space in your memory sometimes when it's one type instead of the other, but you're gaining a regularity that's much more powerful. And so it's always worth noting that combining things together and treating them uniformly can have benefits that have nothing to do with the traditional object-oriented sense of polymorphism, right? You can get benefits there that are real procedural benefits that have to do with something the CPU actually does, and that's valuable. So don't shy away from it just because it might seem a little object-oriented-y. It's not. It seems that tracing rays to collect light is a heavy operation. If ray tracing supported GPU hardware was common, would it be fair to say that you would prefer to move the lighting computation to the GPU entirely? Yes. So if you were targeting like a brand new GPU, like an RTX card or something like that, you would just do it entirely on the GPU. Like 10 years from now, this code will be on the GPU for sure. Because everyone probably who's buying games will have a card that can do the ray tracing efficiently, right? Talking to graphics folks, it seems that shader permutation management is a real pain point. On the other hand, you have titles like Doom that use a significantly smaller number of permutations and pipeline states. Or are you saying significantly smaller or significant? I'm not sure what you're talking about, saying about Doom there, sorry. In a more complex 3D title, what's your take on GPU complexity management? How do you design a solution that scales? Well, I guess what I would say there is typically you have to remember that the GPU code itself also has a cost for having too many things. You don't want to have to change shaders like all the time, right? Because all the same things that apply on a CPU usually apply on a GPU as well. Like, I mean, I don't keep up with GPU stuff because I'm not a rendering guy, so I'm kind of the wrong one to ask. But as GPUs have become more complex, they do a lot of the same things that CPUs do. They cache things a lot. And so typically speaking, if you're just dumping 10,000 shaders onto a GPU and just being like, hey, good luck, pal, you know? I don't really know if that's a particularly sane way to go about managing the complexity either. So I would say, you know, my first thought is, yeah, I would try to architect my system so that actually I don't have that many kinds of shaders. and that I can use a smaller number of parametric shaders rather than a higher number of like tightly optimized shaders, because most of the time I think you'll end up actually probably winning out by going for less things. And you can always spot optimize. If you see that one particular shader is used a ton and you want a special case just that one set of, okay, when this particular shader is used with these particular parameters, I see that that accounts for like a lot of my fill time, then write a highly optimized version of that one. That seems fair. But the like approach of let me generate like every possible combination of every shader I might use, that doesn't seem that smart, especially when branching isn't that expensive in a shader if all of the branches take it. So like nowadays, branching a shader isn't that bad if it's not per lane. So something like a constant that's loaded in that's part of the material, that can be pretty cheap. So again, I would say like my first thought is I'd try to get the shader count down, honestly. I would try to move towards a couple basic shaders that do all of the kinds of things you want to do, and focus on getting that to work well. And then I would just I would only break out into more precise permutations when I thought I needed to for performance, like it really was necessary. Real production related question. In Handmade Hero, we have a general idea of how the game should look and feel, like mechanics, art direction, etc. We're tackling engine problems because they're interesting, and I'm very grateful for you doing it. How will the process of tackling things and exploring the engine design would look in a real production environment based on your experience? Say, maybe based on your experience working on The Witness with John Blow. It's really not different, honestly. You always have some idea of what it is that you're trying to do, and you're basing your engine work off of that. And so in our particular case in Handmade Hero, we're like, look, we want to look at these things because they're interesting, or we know we need them for this particular game design, so we're spending more time on those, and we don't spend time on things that I don't think I want, right? That never changes. Even if the answer is we're making a generic engine, well, that's your driving function. You're like, should we explore this case? I don't know. Does it allow us to expose a feature on the generic side of things that people can like turn on and off and use? If the answer is yes, we go down that route, right? And so typically you just always have some function in your brain that's like, should I start doing this or shouldn't I? And that can be as simple as I ask the producer on the project where the priority is for this thing, or it can be as complex as I sit down and figure out how many different ways I could use this thing in a generic version of this engine that we're going to expose in a UI, right? But you're always doing that. You know, you always have some function, and the function just changes, but the output from the function is still what you use to determine where you spend your time. Tips on reading academic papers about graphics and stuff. I always seem to get lost in their technical jargon and don't really get anything out of them. A good example is your video about GJK in the actual paper. Yeah, skim papers to learn what they've done and what's possible, and don't push it any further than that until you actually want to really do something with some of those papers, and then sit down and actually implement them. Like work it through line by line and make it yourself. That's the only way to really learn them. Because yeah, there's too much jargon, there's incomplete explanations, bad explanations, math that's written as math instead of code for no reason, just because it's convention for them or it makes them feel better about themselves. I don't know. But you have to sit down and really work it through, because you can't just read the paper and learn it. It's not written well enough for that, right? Most papers are not written in a clear and concise fashion, sadly. All right, let's wrap it up. Thanks everyone for joining me for the episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code so you can play around with it yourself. We will be back here next weekend to work on the lighting some more. Again, like I said, there's so many things involved in lighting and it has to be high performance. So it's always takes a long time. So it'll take us a few weekends, but we'll get there. that's what we'll be doing. Hope to see you back here for that. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.